Okay, we're going to go with some general rules of limits. Today you're going to be able to calculate limits by using general rules, and you're also going to be able to do it algebraically. So far you've been able to calculate limits by using a table and also graphically. Today we're going to look at more of a numerical and algebraic approach. So there are some laws of limits. We don't need to cover them all, but let's make sense of these limits so we can understand what they mean. The limit as x approaches a of f of x plus g of x. If you have the limit of a function that has two parts to it, you can separate it into the limit as x approaches a of f of x and add that to the limit as x approaches a of g of x. So what that means is, suppose you had the limit as x approaches 1 of x squared minus 3x. What that means is you can find the limit as x approaches 1 of x squared, and you can find the limit as x approaches 1 of 3x, and just subtract them. Okay? In most situations, you'll just be able to plug it in. You'll be able to substitute it. In this situation, this limit, because this is a very nice behaving function, 1 squared is 1, minus 3 is negative 2. So I'm not going to write out all of these, but as you can see, this is an addition. This would be the same thing. It would just be subtraction. So you could separate it into two things and just subtract it. Here you have c times f of x. You could take a constant and move it out front. C times the limit as x approaches a of f of x. And you'll maintain that equality. If you have two functions that are multiplied, you can separate them and multiply each one. And you can separate them and divide them. Don't worry about number 6. It might just confuse us. It's not really helpful. Let's look at number 7. This is a great example that people get confused with. The limit as x approaches 2 of the function 4. Limit as x approaches 2 of the function 4. What I would like you to do is talk with a partner, think about it, try to come up with anything, maybe even try a picture of the graph, see if you can identify what that would be. Don't say it loud, just okay. Do you agree that the function 4 is a horizontal line? So as you approach 2 from the left, it has a height of 4. As you approach 2 from the right, it has a height of, so does the limit exist? Yeah, so the limit of a constant is simply the constant. Do you understand why? Yeah. So in this situation, so excellent question, we go right back to that. So the limit as x approaches a of c is simply the constant. So in this situation, it would be 4. So if you ever have a constant, you could just choose the constant. What does the graph of x look like? Y equals x. What does that look like? Yep, line with a slope of 1, right? Where whatever the x value is, the y value is as well. Okay, so you would just then plug in a and you would come up with that value. And for general polynomials, there's this really nice thing where you could just substitute in. So as we looked up above here, we saw that you just plugged in 1 to come up with negative 2, correct? So in this situation here, the limit as x approaches a of x to the nth will simply be a to the nth. Just simply plug that in. And if you have the nth root, this would be nth root of a. So you could take the nth root, and it would also work out. Don't worry about part 11. 12 says direct substitution for a polynomial or rational function. Limit as x approaches a of f of x is, generally speaking, f of a. So if we have nice behaving functions, we just simply plug in the number that we're approaching, and that will give us the limit, which works out really well. It's just when we have weird behaving functions, we got to be a little bit more careful. So let's do the easy parts. It says, given that the limit as x approaches a of f of x is 6, limit as x approaches a of g of x is negative 2, and limit as x approaches a of h of x is 0, we want to find the limits that exist. The limit does not exist. Explain why. So the limit as x approaches a of f of x plus g of x can be written as such. limit as x goes to a of f of x plus the limit as x goes to a of g of x. I could take this addition and separate it into two parts. True or false? We know the limit as x approaches a of f of x. What is it? 6 plus -2. So the answer is 4. Yes. We good? Okay. In this situation, notice how it's dividing. So you find the limit as x approaches a of f of x, which is 6, and divide it by 0. Now, there's a difference. The reason why I have this here is there's a difference between undefined and does not exist. Okay? We have big questions about, right? Does not exist would be where we see that the left is different than the right. You don't know for sure that the left is different than the right. So this is just undefined. It's a big question mark. We don't really know. Letter C, limit as x approaches a of -3 times g of x plus 5. Go ahead and just substitute for g of x. The limit is -2. So we have -3 times -2 plus 5. It's as simple as that. 6 plus 5 is 11. Go ahead and do letter D on your own. Letter D on your own. Should get 6. We all good? Can we get an A on that part of the test? Excellent. Flip it over. Here we have f of x. Here we have g of x. We have two different pieces. Limit as x approaches 1 of f of x times g of x. So I want to start with the limit as x approaches 1 of f of x. And I'm going to multiply that by the limit as x approaches 1 of g of x. So let's determine those two limits. Who can tell me what the limit as x approaches 1 of f of x is? It is 3. Notice that you have to approach from the left and the right. Limit as x approaches 1 of g of x? It is -1. So therefore the limit is -3. Is that a little bit more challenging than the previous page? Because you have to use the graphical piece as well as the operation. B, we're going to take, let's approach 0 for f of x. I'm not going to write it all out this time. I think you get the idea. What is the limit as x approaches 0 of f of x? Estimate it. Sure, 2.6. We have 2 times 2.6 minus 3 times, what is the limit as x approaches 0 of g of x? Got a -2. Good job. And so 2 times 2.6 is 5.2. Plus 6, I got approximately 11.2. Letter C, limit as x approaches 2 of g of x. What is the limit as x approaches 2 of g of x? Does not exist. The left must be the same as the right. And you can see that the left and the right are different, are they not? So therefore, if one part does not exist, the whole does not exist. And letter D, limit as x approaches 5 of 2x squared f of x. Let's look at the 5 for the f of x. What's the limit as x approaches 5 for f of x? It is 4. So we have 2x squared times 4. Anybody want to guess what we plug in for x? 4. 5. Yeah, 5 right here. The number you're approaching. It says x is approaching 5, so we plug in 5 there. So we have 2 times 5 squared times 4. 5 squared is 25. 25 times 2 is 50. Times 4 is 200. Still good? Awesome. Let's get to the algebraic piece. Evaluate the limits if they exist. Notice that this is a quartic function. You remember from last year, because you had such an excellent college algebra teacher, told you that you have functions that look like that, correct? You graphed them, you did a great job. Don't do the frown piece. Yeah, there we go. There we go. All right. So they're nice behaving functions. We learned that with polynomials or rational functions, you can just plug in the value. So we have 1 to the 4th minus 3 times 1 squared plus 1. 1 to the 4th is 1. 1 squared is 1 times 3 is 3 plus 1. So just 1 minus 3 is negative 2. Negative 2 plus 1 is negative 1. It's as simple as that. Is a cube root function a nice behaving function? Yep. Yes, it is. You all remember that the cube root function looks like that, don't you? So all we have to do is just plug in 0. 0 minus 27. Can you take the cube root of a negative? Yes. Negative 3. Hopefully you're seeing why I did that little prep with you at the beginning about functions. We talked about square roots, cube roots, things like that. Try to get some of that learning out of the way so that this goes better now. Okay, let's get to the more interesting situations. X squared minus 9 over x minus 3, limit as x approaches 3. Okay, we have a rational function here. We go ahead and we plug in 3, and we get 9 minus 9 over 3 minus 3. That is 0 over 0. 0 over 0 is not undefined. It's what we refer to as indeterminate. Indeterminate. We're going to calculate what 0 over 0 is in this situation. In order to calculate what 0 over 0 is, we will change the problem. Limit is x approaches 3 to, what should I put on the top? Instead of x squared minus 9, I could write x plus 3 times x minus 3. What do you have in the denominator? X minus 3. What do you notice happens? They cancel right here. This is the part that's producing the 0 over 0, right? Like when you plug 3 in, that's the part that's causing 0 on the top. That's the part that's causing 0 on the bottom. So we remove the part that's causing the 0 over 0. So what we have left is the limit as x goes to 3 of just x plus 3. That's the limit that remains. What is that limit? 6. So it turns out that 0 over 0 is 6. Do you need another piece of plastic? Okay, the next one, I plug in 0 to the top, you get 0 minus 0. Plug in 0 to the bottom, you get 0 minus 0. That's a problem. Can anybody see an algebraic trick to working this out? What's that? Yeah, take out the x, and I get x minus 5. Bottom. Factor out that x as well, and you're left with? Notice the x's cancel, and that should be the portion that caused the 0 over 0. You can now substitute your 0 in there. We get 0 minus 5, which is negative 5. And you have 1 minus 0 is 1. So your limit is negative 5. And now you're getting some practice with your algebra. Let's flip it over. You love algebra. It's your favorite thing in the world. We plug in 0 here, and we get negative 2 squared minus 4 over 0. Do I get negative 2 on the top? Do I get 0 on the top? You get 0 on the top, don't you? It's 4 minus 4 is 0. Anybody think of something to do to maybe, I don't know, see what we can deal with here? What would you do? Try something, try anything. Just multiply it out, yep. So we have the limit as h goes to 0. If I multiply that out, what is h minus 2 quantity squared? H squared minus 4h plus 4 minus 4. all over h. What do you notice? Thank goodness that the 4's cancel. And now you have h squared minus 4h all over h. You could factor an h out of the top. So we have the limit as h goes to 0. If I factor that h out of the top, I'm left with h minus 4. And in the denominator, I have that h. Those are now gone. Simply substitute your 0, and we get negative 4. Multiplying that out 3 times takes a while, doesn't it? Do you remember the shortcut? No. You help me out. Oh, keep going. Good. So you remember Pascal's triangle. So this is if we have to the 0 power. This is the first power, second power, third power. So notice that in this problem, is it h plus 1? Is that what we had? H plus 1. So you know you're going to start off with an h squared, right? Or h cubed. And then you know you're going to get an h squared. And then you know you're going to get an h. And then you won't have an h on the end, will you? And then the other way, you have a 1 cubed. You have a 1 squared. You'd have a 1 to the first power, and then you don't have a 1 there. These tell you your coefficients. These tell your coefficients. So h cubed plus 3h squared plus 3h plus 1. Otherwise, you could just multiply it out 3 times. Lindsay saying, I don't remember that. Well, Pascal's triangle, when we multiplied binomials, expanded them. You don't have to know how to do it. It just makes life quicker. If you'd like to see another example at some point, I'd be happy to take you through it slower. When we multiply out h plus 1, we get, limit as h goes to 0 of h cubed plus 3h squared plus 3h plus 1, and then we have that minus 1. See if you can take it through the rest of the way on your own. See what you can do on your own. Go ahead. I've got 3. Good. All right, let me show you a nice technique here. G looks pretty difficult, doesn't it? Looks pretty difficult. I need you to wrap your brain around something, and namely this. Does anybody know what the square root of x times the square root of x is? Can everybody appreciate that that's just x? As you plug in 1 in this situation, you can tell you get 1 minus 1 over 1 minus 1, which is 0 over 0. We have a problem. So I'm going to deal with the top. Most people, when they look at the top, they say it doesn't factor. I'm going to say it does factor. Is 1 a perfect square? Yeah, 1 times 1. Is x a perfect square? Normally we say no, but we just said, what do you multiply by itself to get x? Square root of x, right? So watch me factor. Limit as x goes to 1 of 1 minus the root of x times 1 plus the root of x. It's kind of tricky, but isn't that nice? Because look at those 1 minus the root of x's just go away. If you plug in the 1 at this point, you get dos, which is Spanish for 2. Letter H, we've got limit as h goes to 0. Again, we plug in 0, and we get the square root of 9 minus 3 over 0. Zero over 0? The only way to really get these h's to go away is if I get rid of this radical sign altogether, right? We can't just make it go away, right? Squaring works if you have an equal sign, like you could square one side and square the other. So when you don't know how to do the math, just do Spanish. Yeah. You remember the joke. We multiply by the? So the C rhymes with conjugate. Conjugate, good job. Yeah, way to go. Good. This is going to come back to you. We did this last year. We've worked hard to prepare you for this moment. Okay? She just rolled her eyes at me. All right. So what's the conjugate? Do you remember? It's the same thing. I just changed the sign, change the ending, right? I mean, that's what conjugation means. We take a verb and we change the ending. So you change the ending from minus to plus. It would make my day if Lauren went home and told her mom that we did Spanish and math today. Could you do that for me? Would she appreciate that? Maybe? All right, that's all right. Let's see how this works out. I know it looks ugly, but it's really not too bad at all. Limit is h goes to 0 of. When you multiply these two, what happens? The square roots go away, leaving you with h plus 9. Good job. Now, remember, we are multiplying each part by each part. It's like a FOIL process, right? So when you multiply the outside and the inside, aren't those going to be the same? They'll just be different by a factor of a negative, right? Which means they will. So then you have negative 3 times positive 3, which is? Isn't the numerator pretty? Now, the bottom on the other hand isn't so pretty. We'll just write it like it is, h times the square root of h plus 9 plus 3. What do you notice happens in the top? The 9s cancel, and then what happens with the top and the bottom? The h's cancel with each other as well. So I'm left with just that 1 in the numerator. Due to h divided by h is 1. I plug in 0. 0 plus 9, square root. Plus 3. 1/6. We're going to skip I, but we are going to look at J. Would everybody agree that when you look at J, that it's tough to make a, how do you want to say it? It's hard to make an algebraic reasoning behind that. Sometimes if you can't make an algebraic argument, sometimes you just need to look at the graph. And so remember that absolute values can be positive or negative, right? So suppose I had x plus 5 over x plus 5. What is x plus 5 over x plus 5? 1. Suppose it was negative. Negative x minus 5 over x plus 5. What would you get if you divided those? Negative 1. As you look on y equals here, your absolute value button, if you hit math and number, you should be able to grab absolute value. And I put in x plus 5. And then we're going to divide by x plus 5. Whoop, and I got to make sure I'm in parentheses. And there we have it. What do you notice is the height of the graph down here? Negative 1 when you're off to the left. What's the height of the graph over here? 1 from the right. So if you approach 1 from the, or negative 5 from the left, the limit is negative 1. If you approach negative 5 from the right, the limit is positive 1. Is this a one-sided limit or a two-sided limit? So therefore the limit does not exist. Good job. Excellent work. You guys are super smart.